Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge. The problem is contains duplicate 2. Given an integer array nums and an integer k, return true if there are two distinct indices I and j in this array such that nums of I is equal to nums of j and absolute of I minus j is less than or equal to k. What do they mean? We have to check whether my nums of I is equal to nums of j, and also we have to see whether I have my absolute difference of I minus j is less than or equal to k. We are also given the k, also k in integer k. So let us quickly jump into the example and get a clear understanding. The array is 1 2 3 1 1 2 3 1, and the absolute difference and the index for those elements are 0 1 2 3, and we are given with k equal to 3. So as you can see that we have to find two distinct indices I and j. If there is exist if there are some elements that exist where it satisfies these two conditions, then we have to return true, else we have to return false. So what will be the brute force solution? The brute force will be nothing but for each and every index we will run a for loop from 0 to n, and we will have another for loop where j runs from I to I plus k, because because if j crosses the if the j crosses I plus k, then obviously their absolute difference will not be less than or equal to k. So we can run a for loop from I to I plus k. This for loop will be satisfying this particular condition too, and we have to check this condition. So if nums of I is equal to nums of j, then we can just return true. Finally, at the end of the day, if we couldn't find anything, we can return false. So this will be the brute force pseudocode for this particular problem. So but how we can check in order of n time complexity, or how we can optimize this approach? Let us quickly see. But this will obviously run because this is an EC tag question. So no, it will not be running because it is 10 power 5. Okay, how we can solve this problem? By optimizing it. So what we are doing in brute force is, for each and every index I am checking any other element that is present. I am checking whether there is any element that is present in between I to I plus k. That is what I am doing here. So what I can do is, I can have a map such that I am going to store the index of each element on the traversal of the array. That is, if I have a map, consider I have a map that is going to store the elements, and the index. So if for this example 1 2 3 1, let me say that the element is 1 and the particular index is 0, and we for the next iteration we will go to the next index, and I will check whether the element is present or already in map. Since the 2 is not present in map, I will put 2 and its particular index is 1, and again I will go to the next element and I will check whether the element 3 is present, and as you can see the 3 is not present, so I will put 3 into the map with the particular with this its corresponding index 2. And now the next again I will check whether the element is in map. 1 is in map, but 1 is already in map. What is the index of that 1? The index is 0, and the current index of 1 is 3, and I can say that absolute difference of 0 minus 3 is less than or equal to k, less than or equal to k. So this satisfies the condition. So while I'm traversing the array, if I can store the index of that particular element and check for this condition alone, if it is true, then I can obviously return true, because I have seen an same the element before coming to this current element, such that their absolute difference is less than or equal to k. So this will be the approach for this problem. I will take example 2 and 3 and show what I'm doing again. So the element in the array is 1 0 1 1, and the index is 0 1 2 3, and the k is 1. So I'm having a map. First I'm checking whether this 1 is present in map. Since 1 is not present, so I will put the index, and then 0 is not present, I will put the index. 1 is already present in map, but 1 is the difference, the distance between the current index 2 and 0 is 2, the absolute difference is 2, and it is greater than k. So obviously I will update the index of that particular element, because I need some element which is between I to I plus k, so between the range I to I plus k. So I want to update the index, because this index is no longer needed, because this itself is making a difference greater than k. So obviously I'm going to update it. So now again I'm standing at this particular element. The index is 3. Sorry, here it is 2, right? Okay, this is index. This 2 is index, and this 1 is index. And for this particular element 1, the index is 3, and this 1 is already present in map. So I will see, I'm checking the absolute difference, and absolute difference is 1. So it is less than or equal to k. So obviously I can return true. So hope you are getting the idea for the solution for this approach. So what I'm going to do is I'm going to traverse the array. While traversing the array, I'm going to store the elements in the map and their particular index into the map. Whenever I store the particular index, I'm checking whether the element is present in the map. If the element is present, and I'm finding the absolute difference between them. If the absolute difference is less than or equal to k, then I can return true. If I couldn't find any element that is satisfying the condition, then obviously I can return false. So this is what we are going to do. So let us try to code the approach soon. Int n equal to nums dot size, and I need a map. I will declare an unordered map of int comma int mp. For int I equal to 0, I less than n, I plus plus. If my mp dot find of nums of I is already present in map is not equal to mp dot end, that is already nums of I is present in map. If it is so, then I will get the int j. Int j is nothing but mp of nums of I. So now I will check for the condition. If my absolute difference of I minus j is less than or equal to k, then I can just return true. If this is not possible, then I want to update the index. mp of nums of I is nothing but the current index I, or else this I can do outside the loop as well. It is as simple as that. And finally, if I cannot find any element satisfying the condition, I can return false. So let us try to run the code. So probably it gets accepted. Let us use the example test cases. Superb. Let us submit the code. Superb, it got accepted. Hope you like the solution, and let me know in the comments if there are any suggestions. I will try to improve on them. And the time complexity for the solution will be order of n, and the space complexity is also order of n. For each and every element, I'm going to store their index at worst case. So hope you like the solution. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.